Yeah.
Good afternoon. We're going to get started. I'm Chris Ferguson. I'm an architect for CarMax,
Hi.
the nation's largest used car retailer.
Hi, I'm Pallavi Atle. I'm lead engineer on the CarMax.com platform team.
So today we're going to talk about Azure Platform as Service microservices and how we're using them for CarMax.com. Our story is probably similar to yours. A number of years ago, we decided to go to a service-oriented architecture, and it was good. We created lots of stuff, but we realized that there was complications with regards to configuration, builds and deploys, and we had a lot of nasty dependencies. Also, hosting was complicated. So then we decided to go to APIs, and that was good. Fixed up the configuration, hosting was much better, builds and deploys were much better, but we still had some pretty bad dependencies on databases and things like that. So we decided now we want to go to microsites and microservices. And we want to have a destination that's quick and simple, that's highly scalable, and loosely coupled. So, and we're getting to an organization where we have lots of product teams, and we want them to be empowered to build and control and provision their own segmented software. So, Pallavi, how can we use Azure to make all this happen?
Good question, Chris. So basically, we are thinking about splitting out that monolithic API that we have and building a microservice for one of the resources that's hosted in that monolithic API right now. So let's say we want to create an API for the vehicles resource, right? So what are the PaaS offerings that we would need to build that up in Azure? The first thing, obviously, we'll need an API app to actually host our API. So we'll use the Azure App Service for that. We need some kind of a backing store, so we'll use Azure Document DB or the Cosmos DB now for that. What we also want to do is keep our systems loosely coupled so they're easily scalable and they're fault isolated. So instead of taking synchronous dependency or any other systems for vehicle updates, we'll go with asynchronous event-based processing. So we'll use Azure Service Bus for eventing, and then we'll use Azure Functions for processing the messages that come on the service bus. We also want highly available service. So what we'll do is we'll deploy the API and Azure Functions in 2 regions, East US and West US. And then we'll have Azure Traffic Manager in front of the API so we can actually load balance the traffic to both East and West APIs. Lastly, we'll use the Azure Application Insights for monitoring and health. So now that we know the resources we are going to need, how do we set them up in Azure, right? One way to do it is go to Azure portal and actually handcraft all of the resources that you need. And then you'll have to do it in QA, then in prod. So it's not really repeatable or scalable. So a better way to do that would be to use what are the Azure Resource Manager templates, or ARM templates for short. The ARM templates are just JSON files, and you can. They also accept parameterized inputs. So what you can do is you can set up a very generic ARM template, and then have parameter files to kind of customize it for your dev, QA, and prod. And that's what we'll do. We'll see how to do that in the demo that follows. So basically, in the demo, we'll look at the ARM templates, we'll look at Azure Functions, and we'll look at the event processing and how all that comes together. So let me switch to PowerShell. So basically, what I have here is I've written PowerShell script that deploys my resources. I have 3 of them, and I don't know if you can see this better, but let me just, okay, maybe that's a little better. So what I have, actually, hold on, are 3 set of resources. I've set up 3 resource templates, ARM templates. One is going to deploy my East and West resource group. The second one is going to deploy my application inside service bus document DB, and thirdly, I have traffic manager as its own set. So I'm just going to go ahead and kick this off. And while that runs, let's actually go to Visual Studio and see how these ARM templates are put together. Okay, so as you can see, I have these 3 resource manager templates here. Let's take a look at how each one of them is set up. So you see this templates folder. This is the template file, the ARM template file. And then I have 2 parameter files, one for east and the other one for west. So this is how you can take this to the next level, and you can even set up QA east, QA west, prod east, prod west, something like that, to kind of customize it even further. Let's go back and take a look at our template. So basically, if you look at this, our template actually has 3 sections. Parameters, this is where we are defining what those input parameters are like for this particular template. Then we have variables. This is the section where you can define, just like your code, you define variables that you can then reuse throughout your template. And then finally, the resources that we actually are going to use. So there are a lot of cool things going on here. So let's take a look at some of the resources. The first one is the Azure functions. And the way I'm setting this up is using a dynamic service plan. Now, what that means is it's a consumption-based service plan. So we are going to, Microsoft is going to bill us for only the execution time of those functions and not the time when the functions are at rest. So that actually works really well for us. Microsoft, like Azure, is also behind the scenes going to take care of dynamically scaling the functions as needed for scale, depending on the traffic or depending on how many messages are coming through. So that's really neat. The other thing I wanted to bring your attention to was the list keys. So what you have here, if you recall from our architecture, basically what we are trying to do with the functions is we are going to get messages out of the service bus, process them, and then update the vehicle information in the document DB. So our function is going to need 2 connection strings, one to the service bus, one to the document DB, right? And how do we specify that? Now, one way to do it is hard code that in our ARM templates, but we don't want to keep our secrets in the code, right? So the other really cool way you can do that is using this list keys functions. So basically what this does is once your resources are created, you can say, I want to use that resource by its name. And then when you run the ARM template, Azure is going to, at runtime, give you the actual connection strings that are defined in Azure for that. And you can just plug and play that into your functions when you are setting them up. The other really cool thing that we have going here is with our API. Now, what we have with our API is actually we are setting up a deployment slot for API, so that will enable us to do blue-green deployments. What I mean by that is we have our production API, but we also have a staging API. So anytime in our CI/CD pipeline, we'll deploy all our code to the staging slot, run acceptance tests against it, make sure everything is good, and if everything looks good, then we'll just swap that in for what's live. So that gives you an ability to release your code without taking any downtime whatsoever. Okay, so going back, I have 2 other resources set up exactly the same. So let's just quickly take a look at them. Basically, this one has, so see that? What I'm defining here is my service bus. And then inside, in that service bus, I have one topic called the vehicles topic. And then, so any type of vehicles-related messages in our ecosystem are going to come to that vehicles topic. They can be vehicle updates, vehicles sold, price changes, anything that's related to vehicles. And then anytime an application is interested in specific types of messages, we'll create one subscription for one type. So what we have here is actually our two different subscription setup. one for the detail, and one for sold messages. As you can see, the way I've set that up is there is a filter that actually says the messages I'm going to be interested in are of the type, the message type equal to vehicle update or message type equal to vehicle sold. And that's how we have set that up. The last thing that I have here is app insights. And then finally, my third resource group is traffic manager. And it basically is a very simple resource. It just has two endpoints, one for East API and the other one for West API. So it just defines those two endpoints here, East and West. So let's see if our ARM template actually succeeded. OK, looks like it does. So all of our resources now should be deployed and available for us to use in Azure portal. What I'm also going to do is I'm just going to kick off this build and deploy script, because now that my resources are created, I want to build my code and actually get it deployed so I can start working with it. So let's just kick that off. And while it's running, let's go back to our Azure portal and actually see all our resources in action. So as you can see here, 3 resources, right, in the central. And this is the shared resource. This is where I have my service bus, my app insights, and my document DB. Now let's take a look at document DB. How many of you have dreamed of or even attempted going active-active at your database layer? How many of you still have the scars from that battle on-prem? Right? So let's just see how we can go active-active with document DB at our database layer in this Azure portal. So basically what I have right now, the way I've set this up is I have my write region in East US, but I don't have any read regions. Now I want to go active-active for high availability, so I want to set up a read region in West so that I have a fallback option, right? So all it takes is just going here, picking a data center, and then just selecting it. And I'm going to come back here and save my changes. And that is it. I'm going to be active-active at my database layer. Cool? So the other thing I want to show you is our service bus. As I said, we have one topic here, vehicles topic. And then it has 2 subscriptions, service details and the sold message. So vehicles topic, service detail update, and vehicle sold. Right now you can see that there are a couple of messages in the vehicle sold from the processing, and then no messages in the details update. Let's see if our... OK, so this is where it's still swapping the staging service. So I've deployed all my code to the API staging slot, and now it's swapping it. But looks like my East service is actually done. So let me switch back, and let's go take a look at our East API. So what I'm going to do here is, so you can see I have a URL for my API. I've already taken that and plugged that in here. I'm going to just actually let you guys see it. OK. So what I have here is two endpoints, vehicles and vehicle details. Let's just see if we have anything in here. Oops. Oh, it's because that's still processing. OK, let me switch back to actually 2. Let me switch back to the West service and see what happened, what's going on there. OK. Actually, you know what? It looks like the East one finished, so let's go back and see if this comes back fine. Nope. OK. What we'll do is, looks like my service deployment is still in progress and it's not quite there yet. But what I've done already is I've set up another instances using the same script, same ARM template. So let's just switch back to that and we can continue our demo there. So basically what I have here is exact same thing, just that it's demo 2 that I've set up, and it has, again, 2 endpoints, vehicles and vehicle IDs. Let's see what we have here. So basically there's one document that's already there, and I had set that up just to see that it's all working. Now let's see just all of this end-to-end in action. So Chris, if you would send us a message on the service bus, and let's see if this actually gets updated.
So we have a repository that is distributed. We've got an API, and we've got asynchronous messaging to be able to feed it. Okay.
Cool.
And I just dropped a message off.
All right. Let's go back and take a look at our Azure function and see if it's actually processing that. Is it too small for you guys? Let me just, okay. So this is our function. Let's actually see this in action. Basically, all I have in here is I'm defining my input parameters and output parameters, and then all this function is doing is actually taking in my vehicle message as an input, making sure it's not null, and then setting up my document to be what that input message is. So I'm just picking parameters or properties out of that, putting that in document, and when the function exits, the document DB is going to be updated automatically. So what's happening here behind the scenes is Azure is actually, when it's polling the service bus for a message, whenever a message appears on the service bus topic that I was listening for, it automatically spins up this compute environment for me to run the function. It hosts this function, kicks off the function with the input as that vehicle message. Then when the function runs, it takes that document DB and automatically wires up document DB and updates that. So all of that is happening behind the scenes. I don't have to do any wire up at all for any of that to happen. All I can do is just focus on my business logic and get that done. That is the power of serverless compute, and it's extremely powerful how much actually happens behind the scenes, and you don't even have to worry about any of that. What I'm going to do now is just take this function to the next level and say, now we are taking the message, we are processing it, we are updating the document. Now, if my car goes from saleable to non-saleable, meaning it's sold, I want to generate another message and send that to my service bus so that there are other applications in our ecosystem that are going to take that message, process that message, and do whatever they need to do. As far as the sold vehicles are concerned. So that's how we are going to build the loosely coupled system using service bus as our integration point and asynchronous no dependency communication patterns. So let me switch back to actually my Visual Studio and take a look at the code for that function app. So basically, here's my sold message function. What I'm doing is just setting up a vehicle connection string for the service bus. Rest of the function is exactly the same. All I'm doing at the end is, if the document is saleable equal to false, meaning it's sold, I'm just going to process that and send a message to my service bus. So let's just grab this code, plug that into our function, and just save and run. Okay, now Chris is going to send us another message, same vehicle, but now with sold flag.
Sold.
And you can see that we got that message, we processed it, the completed. Let's go back to our service bus and see if we see that sold message back in our topic. So vehicles message, and you can see the sold message now is 3. You remember this was 2 before. So all of this is working just like we wanted, loosely coupled systems integrated using our eventing.
And that's our time.
All right, so switching back to our present. So that's all you saw. Next steps are, so all the ARM templates that you saw today are available on the CarMax GitHub, github.com/CarMax Build 2017 demo. So feel free to just take a look, use them in your projects as starting points. Another quick link is to the quick start templates, and these are the resources we found useful when we first started with this. So just feel free to take a look at those as well.
And we'll be around if you have any questions for us.
Yep. Thank you very much.